Betelgeuse, a red supergiant in the constellation Orion, has intrigued cosmologists and sky observers alike for centuries due to its massive size and luminosity. This giant star, located approximately 642 light-years from planet Earth, is one of the brightest objects in the observable universe that can be observed with the naked eye. Its astounding sizes are almost unimaginable. If Betelgeuse were centered at the solar system, it would extend past the orbit of Jupiter. Such grandeur has made Betelgeuse the focal point of our understanding of stellar evolution and the life cycle of massive stars. Betelgeuse has, in recent years, shown dramatic and erratic changes in brightness, prompting general speculation among astronomers and fans. The episodes of fainting and brightening are thought to signal the star's last hours, ultimately culminating in a dazzling supernova. A supernova is one of the most powerful occurrences in the universe, representing the death of a star and simultaneously building conditions for forming new celestial bodies. When Betelgeuse finally explodes, it will be an impressive view. A visible occurrence even during daylight and brighter than the moon glowing for weeks or even months during nighttime. The heart of Betelgeuse, like in all stars, has been undergoing nuclear fusion, burning hydrogen to helium. However, as the star ages, it has consumed the fuel of hydrogen in the core and begun fusing heavier elements such as carbon, oxygen, and finally iron. While the fusion of lighter elements does produce energy, iron fusion does not. As a result, the center destabilizes and collapses due to gravity, which results in a catastrophic explosion. Such a star explosion, a Type II supernova, is characterized by an immediate release of energy, radiation, and stellar material. Ground-based and space-based telescopes have been monitoring Betelgeuse closely by astronomers. Neutrino and gravitational wave observatories are at peak readiness, as the invisible particles have a tendency to materialize before supernova light. Neutrinos, massless subatomic particles, can pass almost undeterred through matter, providing an early warning of the star's impending boom. Detectors such as Japan's Super Kamiokande and the Ice Cube Neutrino Observatory in Antarctica stand poised to capture these fleeting particles, giving us a glimpse into the final moments of Betelgeuse. When the explosion occurs, Betelgeuse will release an enormous amount of energy, more in a few minutes than our sun will emit throughout its lifetime. This energy will be present in the forms of visible light, gamma radiation, and other forms of radiation. The shock wave of the explosion will move outward, distributing heavy elements like iron, gold, and uranium into the interstellar medium. These elements play a crucial role in the formation of new stars, planets, and even life. Betelgeuse's destruction will therefore form part of the eternal cycle of cosmic creation and destruction. The Betelgeuse explosion is expected to emit a burst of neutrinos followed by a long burst of electromagnetic radiation. This will be an once-in-a-lifetime opportunity for astronomers to see a supernova work in action. Observatories all over the world, ranging from the Hubble Space Telescope and James Webb Space Telescope to ground-based observatories, will record readings at wavelengths ranging from visible light to gamma rays. All of this information will give us better knowledge regarding supernova dynamics, for example, the reasons that a neutron star or black hole are formed. Betelgeuse's relatively close proximity to Earth at only 642 light-years makes this eruption particularly unique. Unlike more distant supernovae, which are typically obscured by interstellar dust or too faint to be clearly seen, Betelgeuse's explosion will give us a unique view of the cosmic phenomenon. It will allow scientists to refine models of star evolution and core collapse physics and allow us to better understand the supply of heavy elements in the galaxy. Beyond its scientific significance, Betelgeuse supernova will have a profound cultural and emotional effect. For centuries, humans have gazed up at Orion and marveled at Betelgeuse's radiance. The disappearance of so dominant a star from the night sky will be a poignant reminder of the transitory nature of the universe. It will also power new enthusiasm for space exploration and astronomy, bringing attention to the mysteries of the universe and the powers that control it. While the supernova of Betelgeuse will be a breathtaking spectacle, it poses no threat to life on Earth. The star's distance from our planet means that the radiation and cosmic rays released by the supernova will have spread far before they can find their way to Earth. But the phenomenon can have minimal effect on our world's upper air, maybe enhancing auroral displays. The multicolored light shows, typically reserved for polar regions, could appear at lower latitudes, giving observers yet another bonus visual treat. The study of supernovae has extensive and deep significance with regard to our understanding of the universe. The explosions form and emit the heavy elements that make up worlds, stars, and life itself. In making this observation of Betelgeuse supernova, scientists will be taught fascinating facts about those processes that outline the universe. They will be presented with an opportunity to explore associated questions of dark matter and dark energy, the mysterious forces of cosmic structure and universe expansion. Betelgeuse's final act will also illustrate the interconnectedness of heavenly events. The materials scattered throughout the supernova will ultimately form new stars and planets, continuing the cycle of cosmic evolution. This supports the idea that the universe is a dynamic, not static, process in which creation and destruction are intertwined. While we wait for Betelgeuse's finale, the public and scientists alike are abuzz with anticipation and wonder. The starburst will be an unprecedented event, offering a once-in-a-lifetime opportunity to witness the power and energy of the universe. It will also be a witness to how we belong to the universe, encouraging us to continue exploring and searching for answers to the questions surrounding us. Betelgeuse Horizon Supernova is not an exercise in astroscience alone. What it truly signifies is an instance of significant concern to human life. It's the payoff to decades' worth of observation and research and a perpetual question between man and stars. The radiance explosion light of Betelgeuse is at last approaching when it catches our planet and sets ablaze the evening skies, no less but perhaps even the sheer curiosity and sagacity pushing us towards space. This historic phenomenon will leave a lasting legacy on the science of astronomy and on our understanding of the universe for generations to come. Betelgeuse supernova can change the way we understand the universe both on a micro and macro scale. Beyond its immediate scientific and observational benefits, this phenomenon will provide a reference point for a range of advanced technologies. Modern astrophysics has given us equipment far more advanced than anything previously used, enabling a full investigation of the stellar event in ways that were unimaginable to previous astronomers. These developments range from highly sophisticated telescopes like the James Webb Space Telescope to sophisticated computer models that simulate the processes leading up to and following a supernova. The imminent supernova will allow researchers to better simulate core collapse phenomena. Currently, they have to work with observations of supernovae in distant galaxies, where the process is typically obscured by large interstellar distances. Betelgeuse presents them with a nearby laboratory in which to experiment with their hypotheses. For example, researchers will examine the rapid core collapse that results in the explosion and the formation of a neutron star or black hole in the center of the core. This will also resolve outstanding questions about the conditions under which each occurs, completing gaps in our knowledge of high-energy astrophysics. The supernova will also create gravitational waves, ripples in the spacetime fabric, first predicted by Albert Einstein and recently proven observationally. Detectors like LIGO, Laser Interferometer Gravitational Wave Observatory,